Hello everyone, I'm Nat, and today I will walk you through the homework tree from number 1 to 3. So let's get started with number 1. This question asks whether this statement is true. So the impedance of an inductor increases with the increasing frequency. First, we write the relationship of the impedance and the frequency in formula. So it's Z, the impedance, equals to J times omega, which is the angular speed, and times an inductance. You can see right here that the impedance is directly proportional to the angular speed, which is also directly proportional to the frequency. So as the frequency increases, the impedance also increases. So in this problem, we answer true. Okay. Next, when the angular speed approaches infinity, or for high frequency, the inductor is a short circuit. So similarly, we write the formula. Z equals to J times omega and times L. So if the omega is really high, the impedance also increases and approaches infinity. So as the limit of omega approaches infinity of Z, it also equals to infinity. So if the impedance is infinity, then the inductor acts like an open circuit. So there is no current flow through the wire. So the answer for this problem is false. And next, when omega approaches 0, the capacitor acts like a short circuit. So for the capacitor, the impedance, it is Z equals to 1 over J times omega times C. So if limit of omega approaches 0, this impedance will approach infinity. No, because the 0 is in the denominator. So the value of the Z approaches infinity. So similarly, the answer for this problem is an open circuit, and the statement is false. Right. Next, number 4. Which of these frequencies has shorter shorter period? So in the option, it gives us the unit of the omega, the angular speed for letter A, and the frequency, which is the kilohertz for letter B. Since these options are in different units, we are going to convert into the same unit, that is the second for period. So we write the relationship between the frequency or the angular speed with the shorter period, with the period. So it's omega equals to 2 times pi over t, where omega is this value and t is the one we are going to calculate for. So it's t equals to 2 pi over omega. So in this option, the value for the period is 2 pi multiplied by 10 to the power of negative 3, which is the kilo. And for the frequency, we say the frequency is equal to 1 over period. So the value we are going to plug in t equals to 1 over f, which is equal to 1 over 10 to the power of 3. I mean 1 times 10 to the power of 3. You know. Okay, so the answer for the value for the frequency is for the period is the 1 times 10 to the power of negative 3 second. The value of this value is in second. So as you can see here, the value of period in frequency is shorter than in the first option. So the answer for this problem is letter B. It has a shorter period. Okay. Next, number 5. If V1 equals to 30 sine omega t plus 10 degrees and V2 equals to 20 cos omega t plus 50 degrees, then V1 lags V2. So as you can see here, the function is different. So we're going to convert each of these into the same function. Or in another way, we can write this function into a phasor domain. From time domain, we're going to convert to phasor domain. So for V2, the function is already in cosine function. So we can write it as V2 equals to 20 with a phase of 50. And for V1, the function is in sine format, sine function. So we're going to convert to cos function, cosine. So in this problem, you must know the relationship between sine and cosine. So it is the trigonometric identity. If we have sine theta, we can convert it into cosine such that the value inside is the theta minus 90 degrees. So for V1, 30 sine omega t plus 10 degrees will be equal to 30 cosine of omega t plus 10 minus 90 degrees, which is 30 cosine omega t minus 80. Or in phasor domain, we can write it as 30 with the phase of negative 80. So if we were to plot the vector on the graph, we can say that the V2 with an accurate scale, it is 50 degrees, right? So this is V2 and this is V1. So this each of this block is 10 units. So the magnitude of V1 is 30, so we're gonna write with 3 blocks. And for V2, it is only 2 blocks since it has the magnitude of 20. So this is V1 and this is V2. As you can see right here, the V1 definitely lags V2. Because this is minus 80 degrees and this is 50 degrees. So the answer for this problem is true. Alright, next, number 6. The impedance of a circuit is 30 plus J times 40. If the omega is 2, then draw the circuit for this impedance. So as you can see right here, the impedance we are going to analyze is in complex number. So we have the real part and the imaginary part. There is only three options, which is R, L, and C, the resistance, the inductance, or the capacitance. If you can remember the formula to find the impedance for the resistor, we can say that the impedance for the resistor is R. It is not dependent of the frequency and in the imaginary part or something. So the impedance of the resistor is just R, just the resistance, right? And for the inductor, the impedance is J times omega times L. And finally, for the capacitor, the impedance is the 1 over J times omega C. But we can rewrite it as negative J divided by omega times C. Sorry. So the impedance of the inductor, as you can see here, the inductance is always positive, and similarly the capacitance is always positive. So the impedance of the inductor is always positive because it has no negative multiplication. So this is always positive, this is always positive J, and for the capacitor, the impedance is always negative, so it's negative in the J axis in the imaginary part, and for the inductor also, it is in the imaginary part, that is the positive. And for the resistor, it is always positive in the real part. Which means that from the problem given, the 30 is the effect of the resistor. So the impedance is composed of the resistor part, that is 30 ohms. And since the value of the imaginary part is positive, so we can acknowledge that the component used another is the inductor. So we write L equals to 40 and the value is H. Oh, sorry. So this is the impedance, right? So we have to write J omega L equal to 40 J. So we replace the value of omega with 2 because it is 2 radian per second. So it is J times 2 times L equals to 40 J. And we solve the equation by dividing both sides with 2J, and we got L equals to 20 H, which is the unit. So if we are to write the diagram of the circuit, so we may start it with the resistor, followed by the inductor. Oh, sorry, this is not a symbol. Yeah, so we write the value labeled on the component. So the first, it is 30 ohm, and the inductance of the inductor is 20 H. So this is the answer. Finally, number 7 of the main problem number 1, So if the circuit have three sources which do not have the same frequency, which theorem should we use to analyze the circuit? So if you remember the theorem, the answer is superposition theorem. So what is superposition theorem? The superposition theorem states that if there are the component, if we were to find the okay, let's say we have some component and we have to find the voltage. In the circuit, we have multiple sources, such as something like this. We can say that the voltage or the current flow through this component is equal to the effect of each sources acting on it. So if we were to find the voltage of this component, let's say it's C1 something, okay, we say that the voltage acting on C1 will be equal to the voltage coming from the effect of source 1. We say this is source 1 and this is source number 2. So it is source number 1 plus the voltage drop across, which is the effect of the second source acting on the component. So it's voltage of C1 act by the source number 2. So the voltage or the current flow through the component is the algebraic sum of the voltage from the source inside, if we have multiple sources. Right, so this is the answer. Alright, so I'm gonna show you the answer for those who do not follow. So I'm gonna pause it right here for about 10 seconds and you can see how I write the note or how I came up with the answer. Right, next. Alright, so I hope you understand more or less about the homework 3 and see you in the next video.